Good afternoon, everyone. I just wanted to get this started for you so you have the remainder of Chapter 4, and I will post the PowerPoint slides in D2L for you so you have those to study from for your test on Thursday. We have one more section, anatomy of a method, in which to go through. And we're not going to do the graphical objects, the graphical user interfaces, and buttons and text fields like I had mentioned in class last week. So let's go ahead and get started. We've been using methods, and what the methods do is they actually execute the code, and they go step by step when you invoke the method, and they do each individual step. Each statement of the method is executed, and when it is done, it returns back to the location where the call was made to that method, and then the program continues on. The called method is, if it's in the same class, only the method name is needed. So all you have to do is, like it shows you here on the screen, you actually just put in my method and it goes to the method in order to complete the statements. If the called method is part of another class or another object, you have to call the actual object. You go through the name of the object and then you get to the method, and then it will take you through, do each step of that method, and then return back to where the method was called from. Your declaration or your method header, your declaration begins with that header. You'll notice here you have a return type, which we're going to get into next, but you have the method name, which is calc. You then have a parameter list, which is also upcoming, but you notice the parameter list tells the or specifies the type of name of each parameter. It tells it the integer, which is the type, and then the name, which is num1, or you have the integer, which is the parameter type, and num2 is the name. Okay, and then you have string and message. When you have a method, you notice we have our method header right here, car calc integer num1 comma integer num2 comma string message. That is our method header. Then we have inside the squiggly brackets, we've got the method body. It's always followed, your method header is always followed by the method body. You see that it has the integer sum equals num1 plus num2, the car result equals the message.car at sum, and then return result. Your sum and result are all in the local data. You notice it's right here inside the method body, making it local. The return expression has to be consistent with the return type. Okay, your return type is specified in the method header. It can be a class name, it can be a reserved word. If the method does not return any value, your void is used as a return type. Okay. Your method or your return statement will specify the value that is returned. So here you have the return statement, and then you have the word expression, which is what is going to be returned. Is it a string? Is it void? Whatever. But it must conform to the return type. Your parameters. Okay. Let's go back up to the return type, the return statement. If you look on page 174, it gives you in the blue box at the bottom, it shows you how the return works. It gives you the return, then it gives you the expression, and keeps going on. But your method automatically returns, once it's done, it returns to the calling method when the end of that return, or when that return is done. Okay, you can have more than one return statement. However, it's not good practice to do that. And when you do have a return statement, you should have it as the last line of the method. All right, with the parameters, over on page 175, it talks about your parameters. It talks about your parameter list. That is in the header of your method. It specifies the types and the values that are going to be passed to the names. So you notice here on the screen, you have your 25, which is integer one, number 1. You have your count, which is number 2. It's an integer, so it's going to be count. And then you have your string with the message hello that's going to be output. Okay, the names of the parameters in the header for the method are called your formal parameters. And then the actual parameters are called your arguments to the method. So everything in the parentheses are your arguments. If there are no parameters that you need to set, you'll just have an empty set of parentheses that are used. Okay. We've done this before, like in the roll for the dice. It had the empty parentheses. In your get face value method, you had the empty parentheses. Your formal parameters, they're the identifiers that serve as the variables inside your method. And your initial values come from the actual parameters in the invocation. Okay. Your local data, okay, your variables, which are your which can be local, they're inside the method, and what that does is it goes inside the method body. Okay, they're different than the instance data. Your local data's scope is limited only to the method in which it is declared. Okay. When your method finishes, every local variable is totally wiped out. It doesn't exist outside of the method. If you have instance variables, on the other hand, and you declare them at the class level, they exist as long as the object is being used. So, in other words, your local variables can be considered private. Your instance variables can be considered public. All right, you can use the same variables for your local data and your instance data, and they can have the same name, everything, but when you do that, you are going to cause some confusion as to where it's going to be used. You can look at it as, looking at your program. If you do not document your program with your comments, anybody else coming in looking at your program, it's going to confuse them. So you want to avoid naming things that are a local variable and an instance variable the same thing. Not only will it confuse the people looking at your program, but if you go back and look at it a few months later and you don't have any comments in there, you're going to be confused yourself. Excuse me. Okay. All right. Your local data also, when you're using your formal parameter names, your local data for that method, they don't exist until the method is called. So that is another thing you need to know about your local variables. And when the method is stopped, or you come out of the method and you no longer need it, then those local variables cease to exist anymore. So they're only in that local area, or that local method. All right. On page 177, it shows you a bank account class of transactions. Over on 178, it shows you the class account. Okay. It actually looks for the account number, the current balance, and the name of the owner. Okay. Your behaviors of your accounts. You've got different services that you can have. The ones that they use here are your deposits, your withdrawals, and adding interest. Those are the main three services that a bank account does. With the bank account program, it uses the driver program. Okay, we've used this the other night, and we talked about this the other night, where it drives, one program drives the use of the other. It's used to test other parts of software. So with the transactions program and the account program, your transactions class has a method that drives the use of the account class. So if you notice your main method on page 177, you have the account. Notice it's instantiating the account class. You do not have to import the account class because you're creating it. Okay? So your account, your transactions are going to be using the account class and if you take a look at that, you're setting up your account, defining the owner, the account number, the initial balance. You're giving it a constant for the final rate. You're giving it the any withdrawals, what the calculations would be, and you have a return of a balance. For your deposits, you have what your balance would be after you add a deposit. So those are all things that the transaction program is going to use. You notice you have the account 1.deposit, and you have the amount of $25.85. Notice the account 1 is instantiated to use Ted Murphy 72,354 and 102.56. Okay, so those are all part of the program. Here it is on the screen as well, that you have all of these items here for the transactions. You'll notice that on the screen here you have Smith balance after withdrawal. Okay, Smith balance, he has a withdrawal of account 2.withdrawal. If you look at the account class, you have your public account, you have your string owner, long account, and double. Notice here on this screen we have our public double withdrawal. You have double amount and double fee. We use double because we are using our decimals. We could use float as well because it also uses decimals. Okay, so either one. In our case, we normally use the float just because it takes up less space. Okay, double is twice the amount of memory that it needs to store it. Okay, you will notice down at the bottom the string to string. It shows you exactly how it's going to output because it is tabbing. It's tabbing from the account number to the name to the balance. If you look at the bottom of page 177, it shows you exactly how that is going to output the string with the tabs in there. Okay. This is another way that you can depict your bank account example. Okay. You have your account 1, gives you the account number, the balance, and it puts the name in there. Then you have the account 2. You also have the account 3 that it shows you on page 180. You can improve on the bank account class. You can set your getters and setters, could have been defined. You can also design some methods that could be more robust, such as the amount parameter to the withdrawal method is positive. You don't want to go into a negative account, that kind of thing. Alright, constructors. We've been using constructors. It's a method that is invoked when the object is instantiated. You've been doing that, whether you realize it or not. You usually define a constructor to help set up the class, and it initializes the variables that are associated with each object. Your constructor differs from a regular method in two ways. Number one, the name of the constructor is the same name as the class. And your constructor cannot return a value and does not have a return type specified in the method header. So you want to make sure you know those two things. A mistake that's made by programmers is putting a void return type on a constructor. Even if you put a void on there, putting any return type on a constructor turns it into a regular method, so it's no longer instantiated. It cannot be invoked, and it leads to error messages. So you have to make sure that you do not put a return on a constructor. Okay, that is the end of those slides. But at the bottom of page 181, that last paragraph, you don't have to define a constructor for every class. Each one of them, each class, actually has a default constructor. So it's used if you, that default is used if you don't provide your own, and it has no effect on the newly created object or anything like that. So but like I said, we've been using constructors. We instantiate them. You know exactly what, how to instantiate them, and you import some of the scanner classes and you instantiate those. Okay. So what I would like for you all to do now is take the time to do like we've been doing in class. Do the account listing, do the transaction listing. That way you have practice putting that information into the system. I also would like for you to do, and they are listing 4.3 on page 177 and 4.4 starting on page 178 going over to page 179. What I would like you to do for those is to also do the IPO chart, the data dictionary, and the pseudocode for that. You don't, you can turn those into the in-class exercises for chapter 4 in that Dropbox that I created the other evening. So you can turn both of those into that one Dropbox along with the ones we did in class the other day. If you have any questions, please shoot me a text or shoot me an email, and I will be certain to get back to you. I hope you all have a good evening, and I will see you on Thursday.